Every industrial revolution creates a bill. The AI revolution is no different. The difference is that this bill is arriving before the profits are fully proven. Every time you ask an AI a question, generate an image, or use an AI assistant, the experience feels almost weightless. You type, you click, and the answer appears. But behind that simple screen is a physical machine. Servers, specialized chips, networking equipment, cooling systems, buildings, power lines, backup generators, and enormous amounts of electricity. The AI revolution is not happening inside your laptop. It is happening inside giant data centers, buildings most people will never see. And those buildings are consuming power at a scale the electricity system was never designed to handle. So the question is no longer whether AI will change the economy. The question is, who is going to pay for the infrastructure that makes it possible? In 2024, data centers around the world consumed roughly 415 terawatt-hours of electricity. That was about 1.5% of global electricity consumption. According to the International Energy Agency, global data center electricity consumption could more than double by 2030, reaching around 945 terawatt-hours. Artificial intelligence is expected to be the most important driver behind that growth. An AI-focused data center is not just another office building. The IEA estimates that a typical facility can consume as much electricity as roughly 100,000 households. The largest facilities under construction could require around 20 times more. That means one data center can create the electricity demand of a small city. Now look at the money. Alphabet, Amazon, Microsoft, and Meta are projected to spend close to $700 billion on capital expenditure in 2026. That money is going into chips, networking equipment, cloud infrastructure, power systems, and massive new facilities designed to support AI workloads. They are spending money today, hoping that AI revenue will become large enough tomorrow to justify the cost. But capital expenditure does not automatically create profit. It creates buildings, equipment, depreciation, electricity bills, maintenance costs, and financing pressure. Amazon has announced plans to spend around $200 billion in 2026. Some analysts expect that spending level to push Amazon's free cash flow into negative territory. Alphabet has discussed capital expenditure of up to $185 billion, while Meta has indicated that its capital spending could reach around $135 billion. These are infrastructure bets on a technology whose long-term demand is still difficult to measure. That is why investors are watching free cash flow almost as closely as revenue. A company can report growing sales while becoming less financially flexible if every additional dollar is absorbed by data centers, chips, and power infrastructure. And the spending race creates another problem. You can build a data center faster than you can power it. The buildings are going up, the chips are being ordered, the money is being committed. But electricity cannot simply be manufactured overnight. Deloitte estimates that power demand from AI data centers in the United States could rise from roughly 4 gigawatts in 2024 to around 123 gigawatts by 2035. That would be more than a 30-fold increase. Some of the largest planned facilities could require up to 2 gigawatts of power each. That is a major industrial operation. The problem is that the electricity grid cannot simply appear when a technology company signs a contract. New transmission lines, substations, transformers, turbines, cables, and power plants can take years to plan and build. Deloitte reports that some requests to connect new projects to the grid are facing waits of up to 7 years. Imagine spending billions on a facility, only to discover that the electricity required to run it will not arrive for years. The IEA estimates that around 20% of planned data center projects could face delays if grid risks are not addressed. When electricity supply is limited, somebody has to wait. A new factory, a housing development, another industrial customer, or the data center itself. Then there is the question of who pays for the expansion. A giant data center may require new substations, transmission lines, generation capacity, backup systems, and grid upgrades before it produces revenue. In some markets, those costs could eventually affect utilities, investors, industrial customers, local governments, or other electricity customers through higher system and infrastructure costs. That does not mean AI is a scam. It can improve research, automate work, optimize logistics, and create new industries. But technological importance does not automatically equal financial profitability. A data center is valuable only when the computing capacity inside it generates enough revenue to cover the chips, construction, electricity, financing, maintenance, and future upgrades. If demand grows as expected, today's spending may look brilliant. But if adoption slows, models become more efficient, customers refuse to pay enough, or companies build too much capacity, the industry could face an oversupply of expensive infrastructure. That is the hidden risk. The AI economy may not struggle because the technology stops working. It could struggle because the financial return arrives too slowly to justify the speed of the build-out. A technology can be revolutionary and still produce poor returns on investment. So, who pays for the AI revolution? In the best-case scenario, AI generates enough revenue to pay for its infrastructure, making today's investments tomorrow's economic foundation. But if returns arrive more slowly, the bill does not disappear. It moves into lower free cash flow, higher financing requirements, delayed grid projects, rising infrastructure costs, and potentially higher electricity prices. The AI revolution is real, but its most important story may not be happening inside the chatbot. It is happening in the data center, the power plant, the debt market, and the utility grid behind it. Because behind every magical AI demo, there is a physical machine. And behind every physical machine, there is an electricity bill. Eventually, someone has to pay it. The question is not whether AI will change the world. It is whether the world can afford to power it.